for Year 13 Physics on electromagnetic induction in a straight conductor. So whenever a conductor moves at right angles to a magnetic field, the electrons in the conductor will experience a magnetic force, and that will cause them to move. This results in charge separation. Hence, there will be an electric field and a voltage will be induced. And the size of this induced voltage is given by V equals BVL. If the circuit is complete, a current will flow. The size of the current is given by I equals V over R. Now what happens if the circuit is not complete and if it's just a rod? So if rod AB moves to the right, electrons will flow down towards B, leaving the end A with a positive charge. Now charge separation occurs because of the magnetic force experienced by the electrons. However, this charge separation causes a second force, an electric force experienced by the electrons, and this is in the opposite direction to the magnetic force because the electrons will want to move towards the positive charge. So this charge separation will continue till the electric force is equal to the magnetic force. Now, electromagnetic induction in a loop going through a magnetic field. So what happens if there's a loop entering the magnetic field? I use a left-hand slap rule. You use whichever rule your teacher teaches you, and you'll end up with a current that is going anti-clockwise. A voltage would be induced across BC, and because of that, because it's complete, you will have a current going that way. Now, when the loop is completely in the field, then no current flows because there's a voltage induced across BC as well as across AB, and these will be in opposite directions and they cancel each other out. When the loop is leaving the magnetic field, you will have a clockwise current because there's a voltage induced across AD, and because the circuit is complete, a current will flow. Now, in this situation, why is no voltage induced across AB and DC? And that's because the direction of the magnetic force is the same on all the particles. The magnetic force is this way along AD, so that will push the electrons along. But the magnetic force is again in the same direction. Over here, it's acting upward, so it's only these electrons actually just pushed across the sides. They don't flow along the wire, and that's why it is so.